Welcome to lesson 11-4, entitled Reasoning Strategy, Write a Proportion. So this reasoning strategy is going to be writing a proportion from similar triangles to solve for unknown distances. This is something you've seen our geometry class doing when we go outside and they were solving for heights of buildings, the heights of flagpoles with indirect measurements. Without actually measuring the thing, they were able to figure out the height based on similar triangles. Remember, similar triangles and similar shapes in general, they're not congruent. The side lengths are not the same, but they have, remember SCARE, they have congruent angles and side ratios that are equal. This is A over B, this is C over D. So B over A equals D over C. So corresponding side ratios are going to be equal. And the angles are going to be congruent. So I can sweep them. The corresponding locations are going to be congruent angles. So we can go ahead and use this information to solve for unknown side lengths. So for example, in Auburn, which is up north, up above Sacramento on your way up towards Tahoe, you drive through Auburn, and when I was in college, I went hiking around the North Fork of the American River, and we would hike under Auburn Forest Hill Bridge. Our textbook actually has a picture of the Auburn Forest Hill Bridge. So you're hiking down this ravine along the American River. And you can't actually measure the distance of the Auburn Forest Hill Bridge to the stream bed of the North Fork of the American River with a tape measure. It's too hard to measure with just a tape measure. But surveyors sometimes use distances indirectly using similar triangles and proportions. So, for example, if we were to, I'll throw out this example. Actually, we'll get there in a minute. Let's stick with our Auburn Forest Hill Bridge example first. So, if we have the Auburn Forest Hill Bridge here, this is not drawn to scale, but you want to find from the bridge down to the river, this length. You want to find length RS, the distance from the bridge down to the river. And it's way too tall for your tape measure to reach. So one way you can measure this is to pick a one pier of the bridge, so say QT, that you know is perpendicular to the bridge. You know RS is going to be perpendicular to the bridge as well. So now I have, let me highlight here, now I have two triangles, triangle PSR, and then I have this smaller triangle, triangle PTQ. So you have triangle PSR, and you have triangle PTQ. They each have a right angle, and they both share this angle here, angle P. So if you have two congruent angles, you know that the third must be congruent as well. So now we know that we have congruent angles. And by knowing that you have even just two congruent angles, you know that you have similar triangles by angle-angle similarity. So you know triangle PSR is similar to triangle PTQ by angle-angle similarity. So now that we have two similar triangles set up, we can use some of our known. We know that this pier right here is 520 feet. We know we can measure just by walking along and measuring on this bridge the length of PQ. We can also measure the length of PR. So we can go ahead and let's start by trying to just understand the problem. Step 1, we're given certain information. So we're given a couple different things. RS is perpendicular to RP. In the diagram, it's marked that they're perpendicular. We're given that triangle PSR is similar to triangle PTQ. We know that QT, segment QT, equals 773.8 feet. That's marked on the diagram. We know that RQ equals 312.7 feet. And you know that QT equals 520 feet. And what are we asked to find? We're asked to find segment RS. Okay, so we're going to make a plan. Our plan is, I'm going to go ahead and redraw these two triangles. Oops. Step 2, make a plan. And I'm going to use similar triangles, what I know about them in order to carry out and find our segment RS. So I'm going to redraw my two triangles here. So if I have QT and P, PS and R, I know these are congruent angles. I know that angle Q and angle R are each right angles. QP I know is 773.8 feet. RP I can add up QR and QP and get 1,806.5 feet. QT they gave me was 520 feet. And this RS is my X, or my unknown side length. So my plan, I know, remember scare, I know that similar triangles have congruent angles and ratios that are equal. Well, I'm not looking for anything to do with angles, but I am looking for a side length. So side ratios or side lengths that create ratios that are equal, I can use that to then go ahead and set up a proportion. So I'm going to set up a proportion. Step 3, carry out the plan. So in carrying out this plan, I'm going to set up a proportion of my corresponding sides. So QT and RS correspond. QP and RP correspond. So I can set up those side ratios equal to each other. That would be QP over RP should equal QT over, oh whoops, setting that up wrong. QP over QT equals RP over RS. That's my side ratios are equal, what I know about similar triangles. So I can plug in what I know, 773.8 over 520 equals RP is 1806.5 over X. I can solve this proportion, cross multiplying. Write out my cross product, 773.8X equals 1806.5 times 520. Plug that in my calculator. 773.8x equals 564,980. Divide everything by 773.8. In order to get x alone, and then x is going to equal approximately 730.14. So I'm going to round to the nearest whole number. RS, the distance from the bridge, the center of the bridge down to the American River is about 730 feet. Whoops, that's dyslexic. About 730 feet. Right, so if I were to go back and look at this picture, this one here goes down to the American River, this pole. Oh, sorry, not that pole. The center of this bridge here goes down to the American River. That is 730 foot drop. Approximately. So writing proportions, you can solve for unknown side lengths. So I'm going to go ahead and have you do some in-class practice with this using proportions. So setting up and you're solving indirect side lengths. Because you know 2 side lengths you can measure, or sorry, 3 side lengths you can measure, and there's one that you can't measure. You can go ahead and use a proportion to solve for it. So again, like, if you know your height, and you know how far you're standing from so say you know your height is 5 foot 6 inches. And you know you're standing 5 feet from a big basketball hoop that you don't know how tall it is. So you have your height, you have the side length, the length there. You also have the length of your shadow. Say the length of your shadow is 3 feet. Oops. And so you know the sun is shining up here. Maybe. And the sun is making essentially a triangle here. And so the angle from the sun is going to be the same. Right, so this angle and your angle of your shadow is going to be congruent. You know the you and the basketball hoop are both standing at right angles. So now you have 2 similar triangles. Right, you know, your small triangle where you are is 3 and 5 foot 6. You know this long triangle here is 8 feet from where the shadow of the basketball hoop meets the ground is 8 feet. And then X, and you can solve for that unknown side length using similar triangles. So I'm going to have you do some in-class practice with this. I'm going to have you do 1 through 5 on page, numbers 1 through 5, on page 588 in your textbook. I know there's a lot of problems, and they are some word problems, so don't be afraid to ask Ms. Wall for help if you need it. Just know that they're pretty fun problems, and it's rather neat to think about how you can apply similar triangles to these like real life situations and find unknown side lengths, like the height of a building or the height of a bridge. It's really fun. So try to have fun with this lesson. Your homework is going to be the practice book page, reasoning strategies. You're going to be using all sorts of reasoning strategies for 11-4. Whoops, it's not 11. Ah, I want to write H instead of 11. 11-4 practice book page. Alright, go ahead and get started.